Hi everyone, let us solve this together. A minibus of mass 2000 kg traveling at a constant velocity of 36 kilometers per hour collide with a stationary car of mass 1000 kg. The impact takes 2 seconds before the two moves together at a constant velocity for 20 seconds. We are required to calculate the impulse force and the common velocity. So let's start. In order to obtain the common velocity, let's assume that the common velocity is given to be v, and we all know that momentum p is always given as mass of the body times the velocity. You know that the unit for mass is kilogram, and the unit for velocity, the SI unit for velocity is meters per second. So which means the SI unit for momentum is kilogram meters per second. And for every collision, momentum is always conserved. So momentum before collision should be equal to momentum after collision. So let's now find the common velocity v required in the equation. Now, in order to find the common velocity, we need to find the initial velocity before collision and after collision. So let's take for the mass for the minibus to be 2000 multiplied by 10, and this 10 is the initial velocity. In the equation we are given as 36 kilometers per hour. You need to change that one into meters per second, because that is the SI unit for velocity. That is why we have this 10 here. So plus 1000 times 0, because the initial the car was stationary, so the initial velocity is 0, which will give us the summation of the two masses times the common velocity here that we are requiring. Remember the unit, the unit is indicated. Remember to know the unit, because this one is now in kilogram for the, this one is kilogram meters per second, and this one is now kilogram times v. So here, in order to get v, make v the subject of the formula, and remember this is kilogram meters second over kilogram. So kilogram will cancel with kilogram, and we will obtain with meters. So this one cancels this one, then you divide 20 by 3 to get 6.67 meters per second. This is now the common velocity that we are required. Now let's find the impulse. We know that from the definition, impulse is the product of force times time. You know the SI unit for force is Newton, and the SI unit for the time is second. So the SI unit for impulse is given as Newton second. And from the Newton second law, we know that the force is given as the rate of change of momentum. If you rearrange this equation, you come up and get this, the Downer equation, that is force times the time is equivalent to the change in momentum, which means the impulse is also can be also found by finding the change of momentum for the bodies. So in order to find the impulse, you can either use find the change of momentum for the minibus, or change of momentum for the car, stationary car. And this is how we go. Now let us find the impulse for the minibus. Now we take for the minibus, we get 2000 as the mass. Then we find the change in velocity, which is 10 as the initial velocity, minus the final velocity, which was the common velocity, which is 6.67. This for the minibus. If you want to find for the car that was at stationary, we take the mass of the car that was at stationary, then we find the difference in velocity. So the final velocity minus the initial velocity. The initial velocity for the car was 0, and the common velocity was 6.67. So if you work it out, you are going to get your impulse to be 6,660 Newton second. This is your impulse, and we are required to find the impulsive force. The impulsive force is the force acting on an object for a very short time, and we know that it is different from the impulse. Now, impulse is the product of the force times time. In order to find the impulsive force, we are going to take the impulse over the time. We were given the time of impact, which was 2 seconds. So that was the time we are going to divide with the impulse we already found, then to get the impulsive force. So this is very important. This impulsive force is give us this one. Is found by taking the impulse over time. Now you take the 6660 divide by 2, and remember this is Newton second, and the time here is second. So second cancel with second, you remain with Newton. So if you divide by 2, you get your answer to be 3330 Newton. This is the impulsive force F. Okay, hope you enjoy. Goodbye. Thank you for watching.